Theoretical recap. C/CD stands for Continuous Integration and Continuous Delivery, or Deployment. It is the backbone of modern DevOps, and by extension, DevSecOps, workflows. Continuous integration means that every time a developer pushes code to a shared repository, an automated process kicks in. The code is built, tested, and validated without human intervention. Continuous delivery ensures that this validated code is always in a deployable state, ready to be shipped to a staging or production environment at any moment. Continuous deployment goes one step further. Every validated change is automatically deployed to production. A simplified C/CD pipeline typically flows through these stages: code, build, test, security, scan, deploy, monitor. Each stage acts as a gate. If a stage fails, the pipeline stops and the team is alerted. This is exactly where DevSecOps enters the picture. Security checks, SAST, DAST, SCA, are embedded inside the pipeline rather than bolted on at the end. A common beginner mistake is to confuse continuous delivery with continuous deployment. Remember, delivery means the code is ready and could be deployed. Human approval may still be required, while deployment means it is automatically pushed live with no manual step. Another frequent confusion is treating the pipeline as a linear script when, in reality, it is a series of automated jobs that can run in parallel or conditionally. Mini example. A developer commits a login feature, the pipeline builds the application unit tests, run a SAST tool scans the code for SQL injection vulnerabilities. If all passes, the artifact is packaged and staged for deployment. Workshop brief. Now that you have been introduced to DevOps and the DevSecOps concept in the previous lesson, this workshop asks you to make that knowledge concrete and visible. The goal is not to build a real pipeline, you have no infrastructure requirement here, but to demonstrate that you can mentally and visually break down what a C/CD pipeline looks like, what each stage does, and where security fits in. This is a foundational skill. Before you can secure a pipeline, you must be able to read and describe one clearly. You will produce a visual diagram of a simplified C/CD pipeline accompanied by a written explanation. Your diagram does not need to be a polished infographic, a clean hand-drawn sketch photographed. A diagram built with a free tool, Draw.io, Excalidraw, Miro, or even PowerPoint, or a well-structured ASCII diagram are all acceptable. What matters is clarity, accuracy, and the quality of your annotations. Step 1. Define your pipeline stages. Start by listing, in order, the stages your simplified pipeline will include. You must include at least 6 distinct stages. For each stage, write 2 to 3 sentences explaining what happens technically during that stage, who or what triggers it, and what the expected output is. Do not limit yourself to copying the recap above. Think about what you have learned and what makes logical sense in a real development workflow. Ask yourself, what would break if this stage were skipped? This reflection will sharpen your understanding of each stage's purpose. Step 2. Identify where security integrates. Once your stages are defined, go through your pipeline and explicitly mark where security actions occur. You must identify at least 2 distinct security integration points and name the type of security check involved. For example, static code analysis, dependency vulnerability scanning, dynamic testing. For each security checkpoint, briefly justify why it is placed at that specific stage in the pipeline rather than another. This is a critical thinking exercise. There is no single correct answer, but your reasoning must be coherent and grounded in what you know about the difference between SAST, DAST, and SCA. Step 3. Build your visual diagram. Using any tool or medium you prefer, create your pipeline diagram. Each stage must be represented as a distinct block or node. Use arrows to show the flow and direction of the pipeline. Annotate each block with its name and a short label describing its role. One line is enough. Highlight your security checkpoints visually. Use a different color, a border, an icon, or any convention you choose, as long as you include a legend explaining your visual choices. The diagram must be readable by someone who has never seen a pipeline before. Step 4. Write your explanatory note. Alongside your diagram, write a short explanatory note of 200 to 350 words. This note must answer the following questions in a flowing, structured way. What does your pipeline protect against at each security stage? What would happen if a vulnerability were detected at the SAST stage versus at the deployment stage? How does the pipeline respond? How does your pipeline reflect the DevSecOps philosophy of shifting security left? You are not expected to be exhaustive, but you are expected to demonstrate that you understand the logic behind the structure you have drawn. Step 5. Self-review and submission. Before submitting, review your work against this checklist. Does your pipeline have at least 6 stages in a logical order? Are at least 2 security checkpoints clearly identified and justified? Is your diagram readable and annotated with a legend? Does your explanatory note answer all three questions? Is your reasoning coherent and grounded in the course concepts? Once you are satisfied, export or photograph your diagram and combine it with your explanatory note in a single document, PDF, image with text, or any readable format, and submit it before the deadline. Advice for overcoming difficulties. If you are unsure where to start, begin with the most obvious stages: code, build, test, deploy, and then ask yourself what is missing between each pair. If you struggle to place security checkpoints, revisit the definitions of SAST and DAST from your previous lessons. Their names tell you a lot: static versus dynamic, meaning before versus after the application runs. If your diagram feels messy, simplify. Fewer details with clear labels always beats a complex diagram that is hard to read. Do not overthink the tool. Clarity of thinking matters more than visual polish here.